Okay, continuing with the videos to give you homework 1 examples and solutions. Here's problem number 3, and basically what we're doing here is we're taking these two, the P and the G defined here. These are both propositions, and P is the proposition that he has a good job, G is the proposition that he has finished his degree, and we're supposed to translate the following 3 statements into symbolic form. Okay, so he has not finished his degree. That would be a not P, or a not G, and he has a good job. So part A would be not G and P. Okay, he has not finished his degree. That would be not G and P. For part B, either he has finished his degree, either G, or he doesn't have a good job, or not P. Notice that this is equivalent to P implies G. We've worked on that, and the logic here is that either P or not P is true. One of those is true, and if P is true, then that implies G is true, and so we have either not P or G being true. Okay, and that's what we have over here. So that's P implies G. Just by the way, for part C it says if he has finished his degree, then he has a good job. So this is an if-then statement, but this one is if G, then P. So these are different statements, and that's problem 3. For problem 4, we have the predicate, or the propositions are that John is not focusing on his work, and S, that John has a lot of work to do. Translate the following statements. John has a lot of work to do, but he is not focusing on his work. And so we realize that when we have the word but like this, that really means and. It means both things are true. We're stating that both things are true, and so John has a lot of work to do is S. So for part A we have S, and he is not focusing on his work, and not focusing, already the word not is already in R, so it's S and R. For part B, either John doesn't have a lot of work to do, which is a not S, or he is focusing on his work, but not both. If he is focusing on his work, that means it's a not R. And this is an or with a but not both. So this is not a normal or, this is an XOR. And then focusing on his work is a not R. Okay, so if he is focusing on his work, that's the opposite of R, because R says he's not. And so this is part B, and this is not S, X, or not R. You could write it like that if you want. For part C, if John is, so this is an if-then statement. If John is not focusing on his work, then he does not have a lot of work to do. If he is not focusing on his work, that is R. If that, then he does not have a lot of work to do. And here, that's the opposite of has a lot of work to do, so this is a not S. Okay, I can fit one more on this video, and I have problem 5 here. Problem 6 is showing up for some reason, and consider the statement, it's either not raining or the sidewalk is not dry. Use De Morgan's law to write an equivalent English statement that is equivalent to the negation of this statement. Hint, let R be the proposition that it is raining, and let D be the sidewalk is dry. So we're going to write this statement in symbolic form, negate it, then apply De Morgan's law. Okay? So let's write this statement down now. Statement is either it's not raining, that would be not R, or the sidewalk is not dry, and that would be not D. So we want to negate it, and so we're going to negate it. Okay, and sometimes I make a squiggle for the not, and sometimes I just make what looks like a minus sign. They're the same symbol. Okay, so I've negated it. We want to find a statement that's equivalent to the negation of that statement. So I've negated it. Now I'm going to apply De Morgan's law. And when I take this minus sign in, it puts a minus sign on both things on the inside, the minus R and the minus D, canceling them both and changing the or into an and. So this is R and D. And so now we have a much more simplified statement of the negation. If we negate this statement in English, we could say it is not the case that it's either not raining or the sidewalk is not dry. And now we know that that is equivalent to this statement, which is a lot easier. It is raining and the sidewalk is dry. And I guess I'll write that out for you. Okay, so there's number 5. So this is a statement which is equivalent to the negation of that statement, and we arrived at this one by using De Morgan's law. Okay, there you go, and I hope this helps.